So one technique that they use in college is they'll say A equals B, and B equals C, therefore A equals C. So I wrote it really simply right here, for example, and obviously this example doesn't work, it's kind of a little bit of a joke, but it is the right idea. If you say, my slippers are cozy, and my cat is cozy, then you could conclude that your slippers are the same as your cat, which is not really true, because slippers are not the same thing as a cat, but that's the idea. We're gonna say, like, we're gonna find one equation, find the other equation, and then they're gonna both equal the same thing, and at the end we'll set them equal to each other. So let's start, we're trying to find out the cosine of A minus B. Now you would think if you were trying to find like the cosine of, I don't know, let's do something obvious. Like, what is 90 degrees minus 60 degrees? 30, right? 90 minus 60 is 30. So if you take the cosine of 90 degrees, which is 0, and you subtract the cosine of 60 degrees, which is 1/2, what do you get? 1/2. Well, 0 minus 1/2 is negative 1/2, right? Is that equal to the cosine of 30 degrees? No. So you can't just say take the cosine of one and subtract the cosine of the other and think you're good. There's actually a formula that has to happen. All right, so I want you to make your first picture look like this and be really specific about it, please. Thank you, Desi. All right, I'm going to call this angle A, right here. And I'm going to call this angle B. Actually, I might switch that. Where's my whiteout? Here. I'm going to switch the A and the B. Yeah. Come on over here. Right there. No, I think that might be stats. Oh, right there. Mid-table. Okay. So I'm actually going to call this big one A and this little one B. If you need whiteout, let me know. I'm also going to color code this so that you can have a chance in understanding it. Good job being patient so far. Doing a good job. So A is this whole angle here. And B is this little angle here. What would you call this angle? No, in like relation to A and B. You see how A goes all the way down? Yeah, do you see how the orange is going to be A minus B? Because if I take the green and I subtract the pink, I get the orange. Okay, green minus pink is orange. We're okay with that? All right, so I'm going to write down here that my orange angle, and if you want to use colors and you want to go grab some colors from the back, you're welcome to. My orange angle is A minus B. Go ahead. In fact, maybe I'll write that it's green minus pink. You're blowing your nose back there and everybody came to join you?
Yep.
Okay.
How many colors are we going to need?
3. I am going to call this angle P, or this point P and this point Q. Now, this is the unit circle, right? So, this point, P, its point is cosine of B and sine of B. That's because this P here has angle B kind of as the reference to it. And do you guys remember how X is always cosine and Y is always sine? Okay. Can anybody tell me what Q is going to be if I wrote it as a point? Cosine of what? Q. Close, but remember, like, this one wasn't cosine of P, it was cosine of B because it's talking about the angle, right? So what's the angle that's associated with Q? A. So this one's cosine of A and sine of A. And now what I'm going to do is I'm going to use the distance formula, which is going to look gross, and it's going to look messy, but I promise you it cleans up really fast, okay? So just deal with the gross, deal with the messy. Here we go.
What was point
Point Q is cosine A and sine A. So PQ, the distance of PQ is the square root of, it looks like I need to take the cosines and subtract them and the sines and subtract them and then square them. All I'm doing right now is I'm using the distance formula. Oops, put two sine A's, this should be sine B. Sine A, sine B. And now what I'm going to do is I'm actually going to act as if we were multiplying that out. Can you guys tell me what, let's see, I'm going to do it over here on like a little piece of paper on the side. If I have cosine A minus cosine B times cosine A minus cosine B, is this too hard for you to see? Yeah? Okay, so if I have cosine A minus cosine B times cosine A minus cosine B, because that's what it is when you square something, right? It's itself times itself. It's not just distributing the square, don't make that mistake. If we put this in a box right now, like a 4 square, or if we put it, like if we did FOIL, can somebody tell me what it would end up being?